One of the issues that we have to deal with on a very regular basis is how frequently is interest going to be calculated? So how frequently is it either compounded moving forward or discounted when we're moving back to the present? And to try to find a way to be able to compare on an equal basis. You'd be familiar with something like this. The big difference that we'd be looking at when we talk about an equivalent annual rate is when you get a credit card solicitation. Typically, the rate that you're going to see on the outside of an envelope is going to be something that is meant to look as more attractive than the effective rate. And that's all an equivalent annual rate is. It's an effective rate of interest. So how frequently is interest going to be compounded? That interest rate that you see on the outside of the envelope for a credit card solicitation is going to be one where it's giving us what would we refer to as a nominal rate of interest rather than an equivalent annual rate or an effective rate of interest. Now, the relationship that we have is going to be presented right here in what an equivalent annual rate is. It says, let's take 1 plus the annual rate divided by small m. And small m is the number of discount periods within a year. So what that becomes, r divided by small m, becomes the periodic interest rate. So, for example, if you had a 12% rate of interest and it was a monthly compounding, then you would find that r over m is just 1%. If it was semi-annual compounding, then 12% over 2 would be a 6% semi-annual rate, and so on. And what it does is it tells us by raising it to the nth power, it gives us a sense of how frequently interest is being computed so that you're earning interest on interest that much more frequently. Since it's a 1 plus rate, after we've ramped that up, we need to take the 1 back out to get a rate as a result. Now, in this case, what it's asking is Bank A is going to pay a 4% interest compounded annually on their deposits, while Bank B is making you an offer of 3.85%. They're going to compound and calculate interest daily. That means every day, in addition to earning your 3.85% on the original amount, you're also earning that on the interest that you've had in previous days. We simply want to know which is the better move, what's the better opportunity here. Now, at an annual basis, this EAR formula is just going to give us back 4% when it's only being calculated once a year. So let's go ahead and pop in place what we've got right here into this expression. So it's equal to 1 plus, and we want to choose the nominal rate divided by small m. We'll close the parentheses, and then we're going to raise this to the power of small m, which appears here in cell C4, and then we're going to subtract 1. Now, by the order of operations, it's doing exactly what we've described down here. It'll take it to that power before it goes through the subtraction of 1. And again, as we said, we would get a 4% rate. We'll copy and paste that in place here. And what we can see is that the 3.85% has an equivalent rate of 3.92%. So it's more attractive to go ahead and simply take the 1-year rate. But suppose this had been a little bit higher. Suppose it had been 3.9%. Now they're getting closer and closer together. Or suppose it had been 3.95%. In a situation like that, Bank B would have offered a better alternative. But the equivalent annual rate gives you a way to be able to go ahead and make that type of comparison.